Welcome everyone to today's presentation by Krumware, SUSE, and D-Zone on accelerating research with data commons, overcoming deployment challenges. My name is Corey Knowles. I'm the managing editor of IT and BI at Technology Vice, and I'll be your moderator today. We are thrilled to be joined by Colin Griffin and Derek Reinhardt. Colin is the CEO of Krumware, and Derek is a SUSE solution architect. In today's talk, Colin will be explaining an easier way for researchers to more quickly deploy study data in a data commons. So please join me in welcoming Colin and Derek.
Hey folks, it's great to meet y'all. Again, I'm Colin Griffin. I'm founder and CEO of Krumware. I'm a practicing software developer as well as architect, and I'm happy to be presenting to you today.
Yeah, and I'm Derek Reinhardt, a solutions architect with SUSE, focusing on the public cloud and enabling those open source solutions in on-premise and in the cloud.
So today we're going to talk about something that's near and dear to my heart. It's part of a project effort with us and Wake Forest University, as well as the SUSE team. We're working with Wake Forest University along with SUSE to develop technologies to enable life-saving research. The concept of a data commons is fairly new to the healthcare industry, but is spreading rapidly. And we want to give you a little bit of background of that today. Our schedule is pretty straightforward. We're going to talk a little bit about the pain and opioid abuse and some of the statistics there that are drivers for the importance of this research, as well as technology challenges for researchers when they get started down the path of implementing a data commons. As well as the journey to developing a data commons and getting that deploying that in production, and then talking about what we learned and what's next. First, we've got a quick video here from Meredith Adams, who we worked with at Wake Forest University, about the importance of this initiative to her.
Hello, my name is Dr. Meredith Adams. I'm a physician scientist that's an NIH-funded researcher in the United States, and I'm partnering with Colin Griffith and Krumware to solve some of the problems that are really relevant to the physician scientists in the United States. Colin's going to walk you through a lot of the details of how we did it and what we did to really get a functional data commons for pain and opioid use disorder. But what I really wanted to bring here was some context on why we did it. Normally in the United States, there's the technical world of research, and then there's sort of the clinical research, and these are very separated spheres. And so having a solution that bridges both the technical and the clinical science and is understandable to the clinical researchers is a very rare thing. What we've been able to partner with and do is actually bring together a lot of those technical solutions and sort of platform advances to be able to really go at what the scientists need to be able to do discovery, to see what's happening with other projects, to connect their work to sort of a larger data ecosystem, and also meet those data standards that we need to protect patient information and have the privacy. While it sounds like a dramatic statement to be saving lives with Kubernetes, having the work that we do clinically with our research be able to be shared and discovered in new ways and that allows us to combine these data will hopefully provide a lot of these solutions to accelerate. And it does actually translate into saving lives, which is amazing.
So the pain and opioid crisis is a huge problem in the United States as well as around the world. And it was a driver for Meredith Adams' research. Her research is incredibly important. And in order to get that research out to the world so that more doctors and other researchers can participate, she needs to host that data somewhere. So that frames a little bit about the background of how this project got started. So the opioid crisis has caused devastation worldwide. And while the opioid epidemic numbers and overdoses are significant, people don't realize that 68% of people with addiction also have chronic pain issues. Additionally, in 2022 alone, opioids were associated with 81,000 deaths across the United States. So it's a huge problem. But thankfully, the National Institute of Health is trying to combat problems like this by putting standards and requirements in place on research to make life-saving information like Meredith's research available to the world. The NIH HEAL ecosystem has begun work connecting $2.5 billion worth of chronic pain and addiction research through their data to help understand how complex and expansive these conditions are. NIH IMPOWR, which is the name of Meredith's project at Wake Forest, is the first network studying this combination of conditions across 11 unique trials. Now, a data commons is a publicly accessible information repository. Ideally as well, the data hosted on the commons is fair, and fair means findable, accessible, interoperable, and reusable. The National Institute of Health is recommending as a part of these studies, and is requiring in some as well, that if you receive grant money as a researcher, you need to also provide this information on a publicly available data commons. I think that's great for the world because that helps enforce that the medical research that is being paid for by taxpaying dollars do not get lost in either failed studies or potentially patented research or other ways of hiding the information away to protect it for intellectual property. So by enforcing that the data is available to everybody, this allows other researchers not involved with the studies to combine the information and draw assumptions and conclusions from the data and hopefully share that back out with the world as well. On the screen here, you can actually see the user interface for the commons at Wake Forest, and we're going to talk about this is an instance of the Gen3.org Data Commons platform from the University of Chicago Center for Translational Data Science. Some other examples of data commons that are really impactful. You can see the Department of Veterans Affairs as well as the National Cancer Institute are major users here. And one of my favorite is Kids First for pediatric research. I think a lot of these different programs are very impactful. If you search data commons, you should be able to find a number of these on your own. But as we're implementing a data commons, many researchers are finding that there are technical challenges associated with getting those deployed. Many researchers are just focused on getting the information up and live. And when they read information online about how to run and host a data commons software, it makes it seem very simple for them, but there are other technical requirements and challenges that we need to be aware of as these get deployed. So healthcare generally has two categories of expertise. That's clinical domain expertise and the technical and informatics expertise. There's a third one in here that isn't really talked about front and center, which is becoming more apparent and is one of the sources. The lack of expertise there is one of the sources for our talk today, which is just the general IT knowledge for how to manage and maintain systems or machines that can support this type of information. So aligning the goals of technical data commons and clinical research data discovery to create a user experience for scientists with minimal data skills is kind of the baseline challenge that we have here. So research teams, when they get started in the data commons journey, have a significant challenge ahead. There's a lot of diversity in the technical challenges or the technical implementations, and diverse means there is no one size fits all. Also, healthcare and associated research industries are high compliance. So data sharing is limited and actively restricted, despite what you would think is everyone would want to share their information and data, but sometimes it's just outside of their control due to those constraints. Also, siloed and fragmented research and invention that happens at different institutions and different places, when not surfaced, results in many different homegrown solutions that are managed separately and aren't shared with the world. Also, researchers have limited IT flexibility and resources when they apply for these grants and when they have their budgets defined. Many times they don't consider for the line item, which is the IT management, the machines, the cloud bills, all of the other things that come with running the research. And then finally, one that I like to highlight is the risk of hype versus reality. In IT today, we have a lot of active conversations that are really exciting about things like AI and machine learning. But the reality is those are very easy to talk about, but very difficult to implement. And so as a researcher who already has limited expertise in those fields, you likely might be more set up for failure than some of the other technical industries. So by surfacing these challenges and providing that awareness, we can help researchers gain the tools that they need to make sure they can focus on their research and what gets done with that information. So what really happens when we go through a data commons implementation? The first thing that obviously happens is a researcher may Google and find a data commons software, something that fits the requirements and needs of their grant, of their research, and hopefully the broader accessibility of their information. Now, Gen3.org is a great data commons platform. It's an open source product that has an active community worldwide and does a tremendous amount of information sharing and community. I highly encourage everyone to go check out that community and that product. It is our favorite data commons platform implementation. Unfortunately, and just by the nature of IT, it probably shouldn't be, it doesn't cover all of the bases from the IT side for the researchers for what is an operational data commons. And we'll talk about what some of those pitfalls are today. So when researchers select something like Gen3 and decide to operationalize, they're going to make some discoveries along the way. So Gen3 is a microservice base. It's really technical. It's a modern software application that runs on something called Kubernetes. Now, a lot of folks might say, Kuber what? Right? One of the most challenging things about Kubernetes is how to spell it. And researchers are finding that out the hard way. Well, Gen3 requires Kubernetes to run, and Kubernetes is kind of the operational brain that says these things should go on these computers and do these things. So researchers say, hey, I need this Kubernetes thing, and they try to go ask their IT departments. But then their IT departments reply, we don't know what that is either. We're not quite ready for it. Maybe there are some other challenges in the way. So researchers and other folks start to question and say, what else do we not know? Why did we go down this road? Was it a mistake? Who knows? Usually they'll end up falling down and saying, has anybody else done this? Can anybody else help me? What does this look like? And that's how we got involved with Wake Forest. Now, we don't want to get technical, but this is a diagram that shows some of the architecture of Gen3. Just to show how complex that is. There are a lot of nice tools and things in here, like Elasticsearch, that we can take advantage of in other ways, but without the in-depth software development expertise, you may not know that out of the gate. Also, we need to understand and learn how to apply this to what's available to us from an IT environment standpoint. So, we have a number of things that are left up to the researcher or to the user, which have increased its complexity. We now have a requirement for in-depth IT expertise and modern technologies that not everyone is prepared for, but are the correct technologies in the long run. We also haven't even started talking about managing the maintenance and life cycle of the applications and other components. As other updates get published by the University of Chicago, how are we going to consume those and make sure that everything runs on our side? For cloud and infrastructure, this stuff has to go somewhere. And so we need expertise to understand maybe Azure, AWS, Amazon, maybe a data center that's on site, any number of locations. We need expertise to understand how to create this operational environment to deploy into. And then there's governance and compliance. The NIH themselves, as well as many other institutions, are still trying to determine guidance that they can provide for how do we run operational workloads like these in a compliant manner. There's a lot of opinion, and there's a lot of people trying to go back and forth to make that determination based on their experience and recommendations across industry, but it's still up in the air. So how can you determine, if you already have limited technical expertise, what your compliance and governance processes need to be, including things like disaster recovery? So finally, a lack of zero trust security policies is something that we like to highlight. Security is something that you can't just bypass. It can't just be a convenience. It needs to be something that's done from the beginning. And security here, even though our data commons is meant to be open and shareable, we don't want to let that data be manipulated or misrepresented in any way. So we need to make sure that that environment is locked down, safe, and secure. So I like this image because to me, this is reflective of a solution like Gen3 that comes with many things out of the box and gets you most of the way there, but is already it's a well-architected but tightly coupled application. And what that means is that, while we can see the components and everything else, I like the analogy of a terrarium, because it's like you can see it, but you can't touch it, can't manipulate it. In the world of IT, we need now the ability to manipulate and to curate. And so we'll talk about that a little bit. So what we need is an operational platform. So if we take a step back from a data commons and we think about a data commons as just another software product, the software product is made up of a number of different components and tools and pieces, and we need a place to run those things. And we need a way to provide those things to our developers and to our researchers. So the CNCF, which is the Cloud Native Computing Foundation, they're the ones in charge of things like Kubernetes. They define a platform as a collection of capabilities, documentation, and tools that support developing, deploying, operating, or managing the delivery of products and services. So we need a platform to run our data commons on top of, so that it can help unlock the potential and unlock the abilities of doing some of the management and maintenance that we talked about. So platforms have several aspects. They're usually portable, resilient, repeatable, secure, compliant, usable, manageable, and they're foundational, meaning they can be built upon. So a number of those things are things that we talked about that may be missing that we need to figure out. And so we want to look at that a little bit. So again, with the terrarium, if we are able to break down some of the proprietary components of something like Gen3, then we're left with something that is akin to a flower in a flower pot, right? Maybe it comes with that base, some of those base tools and components so that it can run on its own, or it can run on a researcher's machine or something there. But now it's exposed, and now we can take that and put it into a bigger box with more plants and other things along the side. So I like discussing that evolution in this case.
Yeah, and I think that's a great place, Colin, as well, of like, you came and, I think you're going to get to it here in a second, but Ranchers by SUSE kind of acts as that soil in those plants, right? So we have this terrarium, we've taken it off, we put it in a pot, and we have Gen3, we have this data commons that we really want to focus on growing our flower, to growing our plants. But the soil is important, but no one wants to think about it. And so I think that platform really lives there as that base level to kind of provide you those core components, those user authentication, some of those security components, the monitoring, kind of those places where you can put things and kind of connect it all in so that you can focus on your data and your application and building it out, so that all of these things kind of work together and you can focus on the stuff that matters and have the platform there to take care of the stuff that's just the tedious stuff, or the things that kind of take up a lot of time if you don't have that platform.
100%. Yeah, and that was one of the reasons that that we chose Rancher. And so, Derek, do you want to tell us a little bit more about Rancher and what Rancher is in the broader scheme?
Sure. So Rancher is platform that sits on top of Kubernetes. So you would install it on top of your Kubernetes. So your Kubernetes could be wherever you may need it. So whether that's going to be in Azure or Amazon AWS or Google, or even in your own data center at your facility. And it sits there, and you can plug everything into it. So all of your application, your data commons, your other applications that are being developed to help you process that data or interact with it. And we provide that single layer where you interact with that. We support user authentication. We have security plugins. We have monitoring so that you can monitor the systems that all of this is running on top of. And it's all designed to be very extensible. So we can take whatever you have and just give you that single pane of glass to look through and to kind of manage your entire ecosystem and your entire platform.
Yeah, so Rancher, and one of the reasons we chose it is, we're big on doing things that are foundational, right? Kubernetes is this massive. It's probably it is the fastest growing technology being adopted, maybe in our history. It's crazy how expansive this thing is. But there's Kubernetes itself, right? Has many different ways that you can implement or manage, but Rancher doesn't take an opinionated approach on that. It lets us kind of stick to the foundational components. So while Rancher is an incredible help and serves a bunch of the needs that we have for operating the Gen3 platform and our other data commons and our other researching tools, it's not 100% necessary out of the box. It's something that improves our experience that we can build on top of, but it's not something that's mandatory. So if you don't want to run Rancher, you can. It's just going to be a lot harder, and you need to build your own platform along the way. And so you still need to understand those components. So implementing Rancher was a way for us to have a shortcut to basically give us all of those management capabilities out of the box, and then focus on putting the application on top of it. So this is a diagram that you could call a platform topology. It's something that helps us understand what are the parts and pieces and components that make up our platform. Before Rancher, if you look at the top, the very top is end user personas. So it's people accessing the system. Here we can see there are some other personas we'd like, but they don't quite have the tools, maybe another connected data commons, maybe governance folks, but researchers and data teams, do have access to some of the tools that they need in this case. Our interfaces are ways that you can access and interact with things on the platform or interact with the platform itself. So here you can see some Gen3, you can see Jupyter notebooks, and some other pieces out of the box. Elasticsearch is there behind the scenes, but it's not totally accessible day one. And then down under platform capabilities, Gen3 out of the box relies on some things with Amazon, but many of our folks aren't going to have Amazon available. We need to be able to make this portable and, like Derek said, even be able to support this on our own infrastructure. So we have some pieces here. And then down at the bottom, those are providers. Those are like IT operations folks that will be supporting management and maintenance. And so here, we might want QA and platform teams and security folks to be able to access, but they don't really have the tools out of the box necessary to do that. So we've got that focused on operations and data teams. So what does it look like when we overlay Rancher? It looks really similar, right? This Rancher diagram from their marketing seems to show that we have some of the same, if not more, operational aspects that Rancher provides and solves, and can give us a lot of those extra things that we needed out of the box. In fact, some of the logos and things are the same as well, even if it doesn't totally overlay 100%. So I really like showing this diagram because it shows how much Rancher really does unlock. So some quick discussion about some technical wins. And I know not everyone watching is concerned about the technical wins. We want to get straight to the business wins as well. But if this gets forwarded to your IT teams, we want them to see some of the things that get realized when you implement a platform like this to get you to your commons. The big one for us is Kubernetes non-experts now have an effective platform to grow with. What that means by providing data teams, developers, and other folks with an operational platform, they can access and manage it the way that they need to. So this lets us do things like maybe we can deploy some other apps on there. Also, we've decoupled the data commons lifecycle from the infrastructure, which means we don't need to make infrastructure changes or other things. We don't need to change servers. We can just focus on the life cycle of the data commons software itself. Also, applications developers or other teams, like we said, they now have a place to ship new apps and integrations and data workloads. And that's definitely important to us because the commons itself is just going to be one component of many researcher tools you will need to draw conclusions from your data, as well as share that data. So by adding that additional ability, maybe we can do things like leverage embedded AI and ML capabilities in the cloud provider and unlock those opportunities for researchers as well, while leaving the data and the data commons in place for that to be accessible by other researchers. And then, of course, we have an operational data commons. There's a long lifecycle and adoption period for data commons, and we've shortened that and made it easier by implementing a strong platform underneath. And we mentioned taking advantage of other cloud provider tools as well. And something that we didn't talk about is like the ability to back up and secure and add some of the additional components we would have had to grow ourselves. But everyone worries about the technical wins, right? Or the business wins, sorry. One of the big business wins is that now your IT staff actually gains oversight, governance, and management capabilities. The researchers may be expected to manage all of these things on their own, and hopefully this is a little bit easier now, but what a better way to involve IT and hopefully reduce some of your operational burden and hopefully free up some of your budget than by creating something that's cooperative where IT can actually participate and develop and work on it the way that they need to. Also, we are able now to introduce zero trust security and security practices. Rancher, we didn't talk about it from the forefront. And Derek, you may want to say something on it too, but Neuvector is an amazing security tool from the SUSE Rancher side of the house. It's Derek, how about you talk about it and tell us a little bit about Neuvector, and I'll say why it's important.
Yeah. So Rancher has a number of components. You know, you can get just the base Rancher. You can use it, as Colin said, without Rancher, because we just kind of sit there. But Neuvector sits there as a security layer that allows for security even between your applications themselves. So a lot of times you see antivirus or things that run at the deepest levels of your computer, but that doesn't necessarily mean that one program can't talk to another. And where Neuvector sits in is right between those two programs. So it keeps that security and make sure that, you're not having data leak between applications or data coming out. Like, you're catching things very early and you're catching them very quickly and very early. And so by doing that, you kind of build out this ability to build that security to, and I think Colin is going to talk about this, it can all be done programmatically, which allows you in the development phase to design your security practices. And so you don't have to worry about going through tedium to configure it. You can just design it once and then push it out with your data commons when you deploy it. And that means as well, if you spin up multiple data commons, you can deploy that same level of security very quickly on every single platform.
100%. And we actually, to make it easier on folks that are watching, we've actually donated the set of Neuvector security policies that we use up to Gen3. And so if you install Gen3 into Kubernetes and you choose to deploy Neuvector alongside to secure that environment, then you can get those policies out of the box and don't have to do any extra work. And that ability to collaborate even on that side is one of the powers of Kubernetes, but also one of the powers of open source. Disaster recovery as well. We've introduced disaster recovery policies and ways of getting the data commons back up and running if something should happen that is unexpected. But one of the key things for us there is if with a good disaster recovery policy and the ability to get something up and running from scratch, it also introduces the ability to get something like new commons up and running from scratch. So by being able to follow best practices for deployment there, we're protecting ourselves and ensuring uptime, but more importantly, we're able to print and stamp new commons quickly. Another big business win is new tools at home, a home for new tools and new apps. There are other tools and capabilities that researchers need. A data commons is not the only thing, it's not enough. And so by providing that home and those tools, we can perform better research and we can make the data commons an advantage and help improve our research and not just be a place that we need to put our data so that we can fulfill our grant requirements. And then finally, data commons, multiple data commons management. Many folks are already having enough challenge getting one data commons up and running, let alone managing multiple. And so again, with the right tools in place, if we print and stamp multiple, it opens up new research opportunities as well, because we have more time to focus on what we're going to research than we are how are we going to do this IT thing. And then finally, speed really is the key one for us. By standardizing a platform and standardizing the tools and policies and making this repeatable and foundational, we're able now to demonstrate and show that we can get, depending on the complexity of the data, right? But we can get a new data commons up and running in a little bit under 2 weeks from scratch, right? Fresh infrastructure and everything. And many of the other commons that we've observed and people we've talked to are taking 8 months or longer to deploy. And so I'm sure a number of folks watching this may be experiencing that hardship themselves. But if you didn't have the platform and you didn't have the IT knowledge before, of course, it's going to be really difficult and time consuming. But hopefully we're able to provide these patterns and these tools so that you're able to get your own up quickly as well. And we really couldn't do that without open, extensible tools like Rancher Prime and the other products from SUSE. So our platform, now that we've gotten everything up and running and we're leveraging Rancher and some of the other tools, this is just an updated interface that shows some of the other personas and folks that we've enabled. So we've done things like introduce Cabana, which is a visualization tool that lets us do things like time series visualization and other things for the data and expose all kinds of nice complex ways of displaying data for end users. And that was already there behind the scenes. We just used the existing tools in place to expose that. So now it's available. And we've also introduced the ability to move and be multi-cloud. So we're not just in one of the cloud providers. We can be in many different providers at the same time, including on-premise. And we've even introduced some proprietary tools from other cloud providers for demonstration there. But this looks a lot more complete now that we were able to implement some of the SUSE collection of tools. On the top, we've introduced connected commons. Governance teams now have tools they need to do regulatory work or come in and check on things. Even developers now have an interface to deploy. We're using a tool called Argo CD, which is popular in the Kubernetes world to do lifecycle management, as well as let us have the ability to deploy new applications and things as well. So you can see here, we have a lot more people that can play in the same sandbox and help us do our research. So just to recap, we've moved now from a commons as this terrarium, this piece that we're not able to manipulate, but it still can run on its own, to we decouple, right, and move this into something that we can replant into another place or let it survive on its own as we take care of it. And then we've expanded into this platform, which can host many tools and many commons and many apps all alongside each other so that they can thrive with many of the same operational tools underneath. And then by presenting a foundational platform and tools that are repeatable, Now we can spread those platforms across the world and hopefully enable many different forms of life-saving research and the sharing of their valuable data. So what's next for these platforms, and where do we see things going? So the big thing that we hopefully see is an improvement in the ability to connect multiple commons and connect with other research needs. So making the connection between technology and clinical research needs will accelerate the science that we all need. I think that's a great statement. And an additional thing, because of platform design, we can now print and stamp and interconnect multiple commons rapidly. So let's drive the expansion here and the standardization. And then again, I think we're going to see a lot more improvement in the ability to interconnect other complementary tools like AI and machine learning tools that are provided by the cloud providers and many other systems. As researchers get more familiar with those tools, we should be able to use those with our commons data as well. Cool.
Oh.
I think that wraps us up.
Well, Colin, Derek, thank you so much for the presentation. It seems you're solving a really big issue that a lot of people don't even know exists, but it absolutely matters. We have a few follow-up questions from the audience today, if you don't mind.
Sure.
First, how do I involve my IT?
Oh, that's a good question. We see it a lot. I think it just starts with consulting, right? Ask your IT what policies, what capabilities they have, but also how you can collaborate with them, right? IT is also short on valuable resources and funding. And so if we can find ways to provide some benefit to IT teams and not just your siloed research teams as well, especially if IT doesn't have the capabilities, putting an operational platform in place like this is very general to your IT needs. There are most likely other initiatives across the institution that need these same foundational platform tools. So I'd say get that conversation started. Look at the SUSE tools. So look at Rancher Prime, Neuvector Prime, Stack State, all of these collections of open source tools that have valuable and really useful enterprise support for it. Take a look at those, and you potentially have the opportunity of standardizing and providing tools to the rest of your institution. And Derek may have thoughts there too.
I think you did a great job at explaining that, Colin.
Well, thank you guys so much. Next, what did you mean by manage other apps?
Derek, I don't know if you want to take that one first, but I can take a stab.
Sure. So Kubernetes can do a lot. It's very much a toolbox that you can build anything on top of. So in this case, we've taken a data commons and put it inside of Kubernetes, but you could have additional, applications, web apps that are going to take that data and process it or transform it or do other things outside of just the standard data commons that, outside of that standard data commons. And so you can then take that and you can have those other applications. You could have things that are completely unrelated to the data commons at all that may be running in Kubernetes. And Rancher Prime and, all of this kind of sits on top of Kubernetes, and it allows you as another way to manage that just on top of Kubernetes alongside or in addition to your data commons.
Yeah, and one thing too that honestly I forgot to put into a bullet that's really valuable is we have to manage and process this data. And so there are ETL jobs and other things that when we ingest this information to put it into our data dictionaries and get that live, those workloads need to go somewhere also. So instead of running those manually and then uploading the data and displaying that, we're automating a lot of those processes using the same tools that we are to manage the commons.
Wow. Another question we got here. Let's see. What does governance mean?
Governance is a fun one. Derek, what do you think? How about you take a stab? I'm sure you've seen types of governance.
Yeah, that is a fun one. Governance, I think, is a way to maintain accountability for that data. So who owns it, where it's gone, what it's done, who has access to it, who doesn't have access to it, and just maintaining that pane of glass into what the data is and where it's going, and knowing what it's doing so that you can control how it's being used or where it's going to, so that's not necessarily just, you're doing all this research and dumping it into a data commons and going, okay, I did it. But maintaining a control or an access, a visibility into what's going on with the data. I don't know.
Sort of a
Colin,
bookkeeper.
Does that seem close?
Yeah, exactly. I think it's that ability to be able to point to something at any given time, or the actualization of it, I guess, is the ability to point to something at any given time and say, yes, we're doing our job. Yes, we're protecting it. Yes, it's backed up, and all of those things. So in the future, when the grant requirements aren't just you have a commons, that it is you are running this in a compliant format and we're verifying this and we're checking in every year, then it becomes a lot more important.
That makes sense. So Colin, tell me, how did you decide to go with Rancher over other options?
100%. It was really important to us as software engineers. So we work in a lot of open source software, and we do a lot of work to standardize some of these applications so that they're adoptable, frankly. And Rancher is one that when we were evaluating they're called Kubernetes orchestrators. So these things that make Kubernetes easier, help do some of the heavy lifting for you. We wanted one that was open source, that was extensible, that we could make improvements to, and that we could participate in the active development for, but also one that had strong enterprise support backing it, that we could hit the eject button if we needed to and run it on our own. But some of the other providers, we found the solutions were so geared to enterprise that it was almost mandatory that you had to buy them and purchase them and then put them in place. And with Rancher, for us, it was very much opt-in. It was, let's go ahead and get this in place and leverage the community and make this core infrastructure. And then let's go get support for it so that we can offload that management burden and make it easier, make it easier for us to get help when we needed it. But having that choice is really important. And SUSE is all about choice. And we really like that. And I wish that more of the open source ecosystem was that way.
Nice. I have one last question for today. Why would I run my own data commons? Shouldn't someone else just host it for me?
Derek, you want to take a stab at that one?
I mean, it can go back to that governance. It can go back to data sovereignty. It can go a lot of different directions. But running it yourself does give you that option, that flexibility to do what you need with that data. When someone else is running it, you're at their whim on when updates happen, what functionality the platform has, anything that you want, you're beholden to them and what gets deployed. Versus when you run it yourself, you can decide that yourself. Yes, there is a little bit more uplift because you now have to maintain that. But with all the work that Colin has done and Krumware, they've really kind of made this operational and made it quite simple to get going. So running it yourself gives you that flexibility, that ability to build in those new ETL forms, to build in those new applications, to build in whatever you need to get that data processed and functional the best way you can for your research.
Yep. I agree 100%. The one thing that I think, let's acknowledge is it's perfectly okay to have somebody else run your commons, right? Just like it is to have any software as a service, like a SaaS product, right? I think if all you're doing is needing a place to host your data to check a box, go for it. Go find somebody that can manage your commons for you and host it there. I think that makes a lot of sense. And the price point might make a lot of sense too. At the end of the day, in these environments, everyone's IT policies are different. Everyone's hardware and environments are different. There's a lot of variety there. And in many cases, you're not going to have the ability to just offload that burden to somebody else, like data sovereignty. There's a lot of other challenges there. And we at least wanted to make sure, and like one of our core principles here was that by making the investment to implement this operational platform instead of just ticking a box, it really unlocks all of these additional research capabilities. And I think that's probably the most important thing for me. If we enable these institutions to do more with this and let the data commons implementation be a driver for that modernization and for allowing other teams and the interaction with other parts of the institution to participate and manage things here as well, it creates this overlap and this energy and this collaboration that we want to see in modern IT organizations, right? And so for me, again, if it just depending especially on your IT policies and everything else, if you need that flexibility, if your IT organization needs the ability to participate, if you need control and data sovereignty, but most importantly, if you want to do more with this and actualize this environment for really powerful research capabilities, then you need to manage it on your own, but you need the tools to help do that.
Well, guys, thanks so much for joining us today. Where can people go to learn more about what you all are working on?
Sure. So for Crum, as our friends call us, or Krumware, you can visit us at www.krum.io. That's crum.io. And for SUSE, Derek?
Same thing, SUSE.com, but SUSE. So it's not spelled like you would sound it out, but SUSE.com. All of our information's there. All the information about Rancher, Rancher Prime, Neuvector, Stack State, all of those things are linked there, and you can kind of get any more information you want from there.
And quick shout out to the University of Chicago Center for Translational Data Science. Definitely go look them up. They're doing awesome work. And the website for the Gen3 platform is gen3.org. That's GEN3.org.
Cool. Well, to everyone watching, we sure hope you found today's session to be valuable and informative. If you have any further questions or would like more information, please don't hesitate to reach out. Once again, thank you for joining Crum at SUSE and D-Zone today, and best of luck as you dive into the world of data commons. Thanks for watching.
Thanks.